Alright, question number 1. An octagon has an apothem of 6.036 centimeters and is constructed from a circle with a radius of 6.555 centimeters. Find the perimeter and the area of the octagon. Okay, B, construct this polygon using a compass and a ruler and verify your calculations. Okay, I'm going to do B first because of the, in order to do A, I need to have a good diagram, and B is asking me to make a really good diagram. So I'm going to do that first. Okay, from a circle with a radius of 6.55 centimeters. Alright, so here's my ruler, and so 6.55 centimeters here. I'm going to make this the center of my circle, right there. Hello. How are you, Julia?
Good, you?
Good, good, good.
One of our
Hi.
math classes. This
Hello.
is our math teacher, Mr. Scruton. Also, really bright class. These desks were just donated to the math department, and you guys have 5 desks. I don't know. So yeah, just really cool. You can do little pods, little seats, book things.
We do a lot of group work. So everyone sits together in a group and we work like that. Hi.
Is that a calculator?
That's a calculator on the wall. That's right.
Does that work?
It works. So 8 divided by 2 should be, I don't know, 4 or something like that. Yeah, it works fine. It's not a scientific calculator, so I always have to like for pi, I have to do like 3.14159 and lots of fun.
You made it?
Pardon?
Buy it or you made it?
You bought it?
Oh no, this was this is from a store, from Staples. Yeah.
Thank you.
You're welcome. Okay, so I'm going to measure what was the radius? 6.555 centimeters. Okay, so I'm just going to put my compass on my ruler. And so 6.5 is here. Okay, and I want 6.55. So I want to get like, not like that's 6.6. I don't know if you can see that. So I want to get it about halfway between 6.5 and 6.6. All right, so that's probably about it. Be as accurate as you can. Okay, so then I'm going to lean the compass in the direction I want to make my circle. And there we go. Okay, I just realized you probably can't see the bottom of the circle. So there we go. Okay, now I'm going to just put because it's an even, if it was an odd-sided polygon, I would just start with a radius and then figure my central angle out. But because it's even numbered, okay, I can draw a whole diameter. Okay, the central angle is going to be 360 divided by the number of sides, and since it's an octagon, we're going to do 360 divided by 8, which is 45 degrees. Okay, so our central angle is going to be 45 degrees. Take my handy-dandy protractor, okay, and put it centered right on that center dot. And I'm measuring 45 degrees, so here's 40, here's 45 degrees right there. So I'm going to draw a line. right to from there, right through the center, I'm going to draw another diameter. Okay, and I can keep doing that. I can keep measuring 45 degrees, all right? Or we could have just gone from here. 45 is pretty easy to get the multiples. So 45, 90, 135, 180. Let's see, is that perfect? That's exact. And then, 180 we already have. Okay, so you can do it that way. You could also just measure, just adjust your compass, and measure the length of the chord here. Okay, now the chord is going to become your side length. So make sure it's exact, and then go around from there, and go around from here, and then I'm done. Remember, you don't have to keep going around here because the diameters will join up to these endpoints. Okay? Okay, like that. All right, so here's my central angles in each case, in all cases, it's 45 degrees, and we're told that this length is 6.555, and we're told that the apothem, which is going to be halfway, now you can measure that with a compass, with a protractor, and half of 45 is 22.5, so 21, 22.5 is right there. So you could do it like that. Okay, you could also bisect an angle. To bisect an angle, you make an arc, okay, which we already have an arc here. Then you put the point where the leg crosses the arc, the compass, and then just make sure it goes somewhere through the halfway point, okay, like here. And then where the other leg cross that arc with the compass, okay, where those two arcs meet, that's going to be halfway. Okay, notice it goes right through that 22.5 mark. I'm just making a little dotted line here. Okay, so this is our apothem. Okay, our apothem is going to meet up with this chord, which is really the side length of the octagon. So I'm just going to draw all the sides. Okay, just like that. All right, so the apothem, we're told, is 6.036. Now on a ruler, that should look very close to 6. Okay, and notice it does. We are so close. All right, so that's pretty good. And no matter where I measure, it should be, okay, approximately 6 on a wee little tiny bed. All right, so that's good enough. Now what we need to know is we need to know the side length, all right? And you see here we have a nice right angle triangle where with this side is 6.036, the hypotenuse is 6.555, and we don't know the A side. So this is my A, and this is my B, and this is my C. Okay, so we're going to use Pythagorean theorem. All right, we're going to say A squared plus B squared is equal to C squared, and we want to get the A alone, so I'm going to subtract B squared from both sides. So if I subtract B squared from this side, it's gone. Whoops. If I subtract B squared from this side, I get C squared minus B squared. So A squared is equal to C squared. Oops. Take away B squared. Okay. Then Our C is 6.555, so A squared is going to be 6.555 squared, take away 6.036 squared, and so A is going to be the square root of that. 6.555 squared, take away 6.036 squared is equal to, okay, so we get A squared is equal to 6.535, let's say. So A is equal to the square root of 6.535. Okay, which is what I had up there. Okay, so square root time, and that gives us 2.5563. Just for fun. Okay, so A is going to be that in centimeters. Now remember, A is only from here to there. It's not the whole side length. So the whole side length is going to be 2A. So S, the side length, is going to be 2 times A. Okay, which is 2 times 2.55631, which is this number, times 2, which is 5.1126. Okay, so that is our side length. So side length is 5.1126 centimeters. All right, so let's figure out the perimeter and the area. The perimeter is going to be the number of sides times the side length. The number of sides is 8 times 5.1126. 8 times 5 is 40, so we're expecting something around 40. So times 8 is equal to 40.9. That sounds good. 40.9001. That's probably enough. Not 00. Not 001. 01. Centimeters. Well, that's fun. Draw a line through that. Is equal to 40.901 centimeters. Okay, so that's the perimeter. The area is going to be the base times the height divided by 2 times the number of sides, right? So it's the area of one of these triangles, and you've got 8 identical triangles. So the base of the triangle is 5.1126 times the height, which is the apothem, which is 6.036, divided by 2 times 8. Okay. Okay, so there's my side length. Okay, I'm going to multiply that by 6.036. Divide that by 2, times that by 8, is equal to 123.439 centimeters squared. And that is it for question number 1. Okay, question number 2. All right, find the perimeter and area of the shape below. Okay, so the perimeter is going to be quite simple. We have just 10 point, sorry, that's not 10 point, that's 13.8 centimeters. Okay, and we've got 8 of these little sides, like 1, 2, 3, 4, 5, 6, 7, 8. So we're just going to do the perimeter is going to be 8 times 13.8. 8 times 13.8 is equal to 110.4. The area is going to be 4 times the area of the triangle. So 4 times the area of the triangle plus this area of the square in the center, plus the area.